Today we're going to start learning about how to do an antilog. So let me put a little shade up here just to make the screen a little less confusing. So this is an example. It's not one of your homework problems. However, this is something that you should write down and copy precisely as I have done it. And from there you should be able to do almost anything. So basically we're going to find out how to do an antilog. So this is a typical problem. You'd be given the POH, and then you have to find the hydroxide ion concentration. We've been working everything the opposite direction. So what we're going to do, and let's just get a block in here so that everything is easy to focus on. So this number right here, the 8.32, is coming from the given, and that is actually a log because it is a POH. And the only way we can get that is to log a concentration, or use a concentration to get to this number. And so what we're going to do is we're going to change this, and it's not going to make a whole lot of sense until you see the whole thing. So we're going to change this guy to 9, which is the next highest whole number. So this is also considered a log. The next thing we'll do is change the sign and make it into an exponent. And this should be something that looks a little bit familiar, because what we did before was we took this 10 to the minus 9 and made it into 9, which is just using the definition of a log. Okay? And the log of 10 to the minus 9 is actually 9. But now we're going the opposite direction. So this part is really simple. What you need your log table for is the next step. And notice I'm indicating here log, log, log. So this is the log that we changed to by the rounding. And this is the original number that we started out with, which was the given. And we're going to subtract those. And that thing is essentially the difference between the 9.0 and the log that we're actually going to come up with. So it's going to be a little bit less. So let's look at that with a larger and more accurate log chart than we have been using. And I'd like you to stop the video and copy this chart down. Okay, there it is, nice and big for you so you can see it easily. So we'll stop the video. Okay, I hope you have it all copied down, and this is what we're going to use in doing what's called the antilog. As you look at this, you can see this column here is known as the regular number that we're all familiar, regular kind of number that we're all familiar with. Well, the technical term for that is an antilog. And in a log table, the log is here and its antilog is here. Just like we did on our little half sheet that you got last week. So this chart is just more accurate. That's all that it is. And I thought we ought to go for a little more accuracy when we go to antilogging. So we're going to antilog using this guy, and when we do that, we'll see that the 0.68, and I probably ought to keep this big, the 0.68 is right between this guy and this guy. Okay, that's a log. So we want to go backwards and estimate. It's going to be between these two, just call it 4.5. That's very, very accurate next to what we've been doing in the past, and that will get you a pretty good number. So here we go. We're going to make that 4.8 or 4.5. Either one is going to work just fine. And then we're going to go down here, and we're going to put the 4.8 out front and take that 10 to the minus 9 that we created up here, and that's going to be together our concentration of the hydroxide ion. Not too difficult. So let's see what we do on the first homework problem. here is your first homework problem, and let's look at this a piece at a time, and then we'll let you loose and you can go ahead and finish your homework. So we're looking here at a pH. Okay, the pH now is given. It wouldn't matter whether it was pH or pOH. We're still going to do the anti-logging in exactly the same way. So here's our find. We're looking for the hydrogen ion concentration. And now we go down here and we're going to do exactly the same process. We take this original pH, which is a log. We're going to take it to the next highest whole number, which is 3. And then we're going to use that as the power of 10 for our anti-log, because this guy is now an anti-log. Now we go down here and we're doing exactly what we did in the last problem. We're going to subtract the original pH from number 1. So here we go. We're going to take this guy right here and subtract it from the 3.00, and the number that we get is this guy. Well, this guy is anti-logged through the table that you saw before, using this as in the log column, taking to this guy, which is the estimate of the anti-log, and then this becomes the number out front of the 10 to the minus 3. And that's it. It's just that simple. I hope you'll find this a little easier even than doing the log. And that's it. Hope this helps.